Hi, today let us solve the following questions under the topic Indices and Logarithm. We have the first question which says, find the real values of x for which 3 to the 2x plus 1 minus 12 into 3 to the x plus 9 is equal to 0. And then the next question, B, x equals e to the ln x plus 2 ln 5 minus ln 20. And then the third one, ln x, all of that squared minus ln x minus 6 is equal to 0. So we want to solve those equations. Find the real values of x that satisfies all those exponential equations. All right, let's start. The first one, 3 to the 2x plus 1 minus 12 into 3 to the x plus 9 is equal to 0. We want to solve for x in this exponential equation. If we look at it carefully, we can see that this exponential equation can be rewritten, wherein we put things in 3 to the power x. Because there's 3 to the power 2x here, there's 3 to the power x here, and we also know that 9 is the same as 3 squared. So we rewrite this equation as 3 to the 2x. Remember, when we write like this, it means multiplied by 3. All right, minus 12 into 3 to the x plus 9 is 3 squared is equal to 0. Okay, now 3 to the 2x, we all know what that means. 3 to the 2x is the same as 3 to the x squared times 3. Okay, let's leave this one there, 9. All right, so we're finally written this exponential equation in terms of 3 to the x. This is 3 to the x squared, this is 3 to the x. So it will make sense if we make a substitution to facilitate our work. Let us make the substitution y equals 3 to the x. So wherever I see 3 to the x, we write the variable y. So our equation now becomes this 3y squared. All right, 3y squared minus 12y minus 12y plus 9 is equal to 0. All right, we obtain this new equation. 3y squared minus 12y plus 9 equals 0. All right, so what do we see? Again, the coefficients here, they are all multiples of 3. So we can simplify this quadratic equation further by dividing all through by 3. If we divide here by 3, we obtain y squared. Divide here by 3, we obtain negative 4y. Divide here by 3, we obtain 3 is equal to 0. So this expression now gives us this simplified quadratic equation. If we apply our quadratic formula, y equals minus b plus minus the root of b squared minus 4ac all over 2a. We know our a, we know our a, we know our b, we know our c. Collect those information carefully. We'll put it in the formula. So y equals negative 4 plus minus the root of negative 4 squared minus 4 into 1 times 3. All of that divided by 2a. Okay. So what do we get? It gives us negative multiplied to negative, positive 4. Positive 4 plus minus the root of negative 4 all squared is 16. All right. 4 multiplied to 3 is 12. All over 2 times 1 is 2. So from here, y is equal to, we take the positive 4 plus 16 minus 12 is 4, the square root of 4 all over 2, which is simply 4 plus 2 all over 2, which is simply 6 all over 2, which is 3. So our first possible value of y is 3, or y equals to take the subtraction 4 minus, we already found that to be 4 We found that to be 4. Okay, no. Root 4 is 2. 4 minus 2 all over 2. This gives us 2 all over 2, which is 1. All right, so the two possible values of y are y equals 3 or y equals 1. But remember, we're asked to solve for x, not y. And we know the relationship between x and y. So we'll go back to that relationship between x and y. Y is 3 to the power x. Now, when y is 3, let's work from there. That means we put 3 is equal to 3 to the x. All right, this is in index form. We can write this one also in index form. 3 is the same as 3 to the power 1. All right, so if this index expression equals this next expression, the bases must be equal and the powers must be equal. The bases are already equal, so we'll have the right to equate the powers. So the first value of x is x equals 1. All right, so we take the next value of y. The next value of y is 1. So we say 1 is equal to, we're using that relation, 3 to the x. Now pay attention. This is index form with base 3. Can we change this to an index form with base 3? Yes. Any number raised to the power 0 is 1. So this one can be written as 3 to the power 0. We're choosing base 3 because this one is base 3. So we should have something with the same base. Right? The bases are equal, so we'll have the right to equate the power. So from here also, we can then say the next value of x is 0. So the two solutions for our exponential equation are the values x equals 1 and x equals 0. Of course, if you put them there, you will see you have the same solution for the left hand side and the same solution for the right hand side. Now let's take the second question. The second question says we should solve the equation x is equal to e to the ln 4 plus 2 ln 5 minus ln e to the ln 4 plus 2 ln 5 minus ln 20. All of this that to the power of e. Okay, now this gives us e to the ln 4 plus ln 5 squared minus ln 20. All right, remember this 2 here simply means the power. This is logarithm. When a number is written in front of the logarithm, it just becomes the power. All right, so this gives us e to the ln 4 plus ln 25 minus ln 20. So all we need to do is to apply the laws of logarithm here. All right, whenever we have addition, it simply means multiplication. So we'll write the ln one time. So 4 multiplied to 25, and whenever there's subtraction, there is division. All right, this gives us e to the ln 4 multiplied to 20 to 25 is 100. Okay, so this gives us 20 here, 20 here, 1, 20 there, 5. So you have e to the ln 5. Okay, now what is e to the ln 5? All right, e to the ln 5 is just, when we simplify it, it just becomes the value 5. All right, e to the ln 5 is just the value 5 from the laws of logarithm. Remember, uh, a to the log base a of anything p will just be that. Okay, and we know that ln is the same as log to the base e. All right, so we apply this law here, we'll have the value 5. So that solves the second equation. Now the third and last equation The third and last equation, we ask to solve the equation. We have to solve the equation ln x, all of that squared, minus ln x minus 6 is equal to 0. Solve for x. So how do we go about that? If we look at it carefully, we see it's a quadratic in terms of ln. Alright, to make it very clear, let us make that substitution. Y equals ln x. So wherever I was seeing ln x, we put y. So our equation now becomes y squared minus y minus 6 equals 0. If we factorize this out, all right, let's use the factorization method. We obtain y minus 3 into y plus 2 is equal to 0. If you expand this out, you get back to this. Otherwise, you can use the quadratic formula and find out those roots. You know how to move from roots to factor and factor to root. All right, so we get this uh, factorization of the quadratic expression, which therefore means, all right, if this expression multiplied to this expression giving us 0, it means either this is 0, which now means that y equals 3, or this is 0, which therefore means that y equals negative 2. All right, now again, we have found the solution in terms of y, but we're asked to solve for x. Again, we'll go back to our relation between y and x. Okay, our relation between y and x is y equals ln x. All right, we take the values. When y is equal to 3, we obtain 3 is equal to ln x. All right, how do we get, therefore, the value of x? 3 equals ln x. How do we get the value of x? Remember ln, we said ln simply means log to the base e. Okay, so ln x is log to the base e of x. So we are saying 3 is equal to log to the base e of x. To get x, we simply take this base raised to this power, will give us the argument x. So from there, we'll say the value of x is e cubed. All right, we'll take the next one. When y is equal to negative 2. When y is equal to negative 2, we'll put it there. So negative 2 is equal to ln x. So negative 2 is equal to ln x, which is the same as log to the base e of x. So to get x, we do the same thing, which therefore means that x is equal to e to the negative 2. So these are the two solutions. The two solutions to our quadratic equation, which was in terms of ln x.